So today is 22 March and let's solve today's question. Before this, I want to discuss my last stream's question which I was unable to submit. The question was this one. Although I got the main idea, but my implementation part was missing. So we had to do, let's see, from here. We have to find the largest rectangle area in a binary matrix in which every subsequent row was a right circular shift of the previous row. So there was a pattern that if we try to simulate and make the whole array first and then somehow find the largest rectangle, then that will be too slow to submit because we have like problems like maximal triangle. If we use that approach, then that will be slow. So I also, although I revised this question just for the sake of completeness, but this is a slow approach. The optimal approach is one in which we calculate the area only from the first row, only from the string which is given in the question, and the largest area will be made by the longest consecutive ones in the string. And in this we also have to take care of the circular part. The circular, like the first is connected to the last, so that part is also important. Hmm. Like I took the first case in which both are 0. So this is how going to be the matrix. I didn't fill here because it will come as symmetric. So if this is two consecutive ones and this will be the rectangles made by it. This is 1, 2, 3, 4, 5, 5 consecutive ones, and we can have 5 cross 1. Then it will shift and this will come here. So we can have this and essentially all shifted here. So this is 4 cross 2 and we can also have 3 cross 3. So we find the longest length and then decrease the length by 1 and increase the breadth 1, then decrease the length 1 and increase the breadth 1 by 1, and see which multiplication results in the highest product. That will be our answer. And to address the circular part here, first we calculate only, we can check like if both are 1. If both are 1, this part, let's see in the below. When one of the start or end has 1, then also it results in same condition because it does not result in a circular connection. So same. Also a important edge case here is if all the string is 1. So answer in that case will be n cross n. And case 3, when both 1 occurs at the starting position and end position. So this part will eventually connect here. So what we can do here is, first we can find only linear part, the consecutive ones, and to find the circular connection we can first check that both this is this and this is one, and we can have I pointer and j pointer here, and we can decrease the j pointer till we have ones, and we can increase the I pointer till we have ones, and eventually when a zero occurs the I will stop, and when in this direction 0 occurs j will stop, and that will be the consecutive circular ones. And same we can check which of the multiplication results in the longest or biggest multiplication. If we see here, then this is 1011, so circular, if we take into account only linear, then this is 1, this is 2. But if we take into account the circular relationship, then this whole is connected, and we can have this with the help of ij pointer, and this will give the biggest multiplication, and this will be this rectangle. This. And this was my, after I solved this problem, I got back to my maximal rectangle approach with DP. I remember that I solved this question with the help of stack, but I was curious how to solve this question with the help of DP, because DP was a problem tag. So I found out that this solution which I found is O into M into N into N. It was in the constraints of the lead code, and it got submitted, and my like, I will not explain all of this, but the main part is my DP state was 1 second. My DP state was like, this was my DP table, and this represent number of consecutive ones in right direction, including current one, and this include number of consecutive ones in down direction, including the current cell one. So this is my DP matrix for the this input, this image input. So we can see here, this is no ones in down, no ones here. So this is base case. If this was 1, then this will result in 1 comma 1, and here it will be 1 comma 1 and 1 comma 1. You can see 1 comma 1, 1 comma 1. This row and this row is base case because we can't go here and we can't go here. So if we encounter 1, then we initialize it with 1 comma 1 and we only update in this direction. For this column and for this row only in this direction. This will be 2 comma, sorry, 1 comma 2. 2 represent this and 1 represent this. 1 comma 2. So filling the DP table, after we get this DP table, we process this. If we choose a cell, then by this we know that we have one, like including current cell, we have one consecutive 1 in right direction and 4 including current in down direction. So initially we take our length as 1, which is given on, we will always take as 1, initially length as 1 and breadth as the given breadth in this cell. So I am stating about this rectangle. This rectangle. For each cell we have to do processing, and for every cell we take first length as 1 and breadth same as this number, and then we calculate its area and it comes to be 1 cross 1 4. Okay, and we save it. Now in the next iteration we compare and we try to extend it with my length to 2, but since here there is no one, we cannot extend it, so we stop, and our area till now is 4. Okay, and if we go here, then we reach here and we do the same processing. So first we initialize our length as 1 and breadth is 3, so this corresponds to this, and our area comes to be 3 cross 1, which is less than our 4 area, so we don't update it, and then try to extend our length, but it is 0 comma 0, so we cannot extend this. We know how much we can extend in this direction due to this number 1, so we know that we can only run this one time. Let's take this 3 comma 2. So we take length as 1 and breadth as 2, so this corresponds to this rectangle, so our area is 2 cross 1. Then we try to extend this and make this length as 2, and for this length our updated breadth will be minimum of the taken cells, included cells, minimum breadth of 2 and 3, it is 2, so this will correspond to this rectangle. Okay, so then length and breadth comes out to be 4, and this also resulted in 4, so it will not update. And for length is equal to 1 rand, length is equal to, now length is equal to 3, we try to extend this and we track down the minimum breadth encountered in this 2 3 2, the minimum is 2, so our length is 3 and breadth will be 2, so 3 cross 2 is equal to 6. This is the maximum area encountered and we will be update this. So For each cell, we have to repeat this process and find the maximum area, and this results in time complexity of O into m, m into n into n, mn square. And the stack solution gives us O into m into n, but this is more intuitive, I think. And I spent like great amount of time to figure out this. I thought this can be my deep state with four variables, two variables. Essentially, I was happy that this solution worked. Okay. Let's move and see today's question. Subsequence addition. The only difference between the two versions, okay, constraints are okay. Initially, array A contains just the number 1. You can perform several operations in order to change the operation. In an operation, you can select some subsequence of A. Subsequence means non-consecutive elements, okay, and add into A an element equal to sum of all elements of the subsequence. Let's write this info initially. Zoom out. Initially array equals 1. We can do operations, and one operation an operation is we take a subsequence of A and add its sum to what? And add into A an element equal to, okay, append this element, add its sum and the resulting element into array. So this results in expanding the array. Okay. You are given a final array C. Check if C can be obtained from the initial array. Final array C is given. And we have to check whether it is possible A from A. Both A and C is given. Okay. A and C we only have a boolean output, yes no output. Okay. Yes. Let's see the expected time complexity. N is so of n square will not better solutions than n square and log n and all faster ones. N square will not work. Okay. This is equal to this. Select a subsequence and add some. Okay. What order we push this element? It is also important. Second test case, performing any amount of operations will change it into a size of at least 2, which doesn't satisfy us. This is true. Okay, if at the time of input, if A is equal to C, then answer is always yes. From inferring from the first test case. If the C should be always greater than A because we expand its length, and if they are unequal and having same length. If A is not equal to C and A dot size is greater than equal to C dot size, then answer is always no. Inference from the second test case. This is B6. Okay. Here we have 5. For the third test case, we can perform the following operations in order by choosing. So given is test case. Test case 3 given is 5 5 1 3 2 1. 5 1 3 2 1 always keeps crashing. 5 1 3 2. Initially initial A is, what are we given? The first line contains n. Number of elements that final array C should have. Final array C that should be obtained from the initial array. We are given a C, but we are not given A. Okay, I thought we are given A. So this is C size and C. Okay, okay. Input is this. Misinterpreted it. C dot size. This is C I. We have to find any array in which it is possible. So A size should be less than A dot size should be less than C dot size. If they are having equal size. Initially always we start from, okay. A is always given as 1 initially. Okay, yes, yes. This is C. Now we extend this. This will always result in 1 comma 1. If we take a subsequence, and this can result to 1 comma 1 comma 2. Or we can make as many ones here. If we take only one element in subsequence, then it means it can repeat. So an element we can make it, okay. This is one we can have. Infinite times. If it is so I will avoid the duplicates now because it will lead to complications. Because we can see that if we take only one element in a subsequence, then it can get repeated. If we take this 2 in the subsequent, their sum is 2 and this new element comes. So yes, it can be made. Okay. Okay, and now we take these two. 1, 2, 3. 3 can be made. Subsequence. Can take any number of ones, any number of twos, any number of threes and add them. So till now we have 3 size. 4 we can also include this. Let's write down. We should sort this to in order. And 5 can be made from these two. So we can get this. So yes. This can be made. One. Okay. We can have as many ones. So we can have as many ones. We can make any element with like this, but this will expand the size. So I think we can make this element as 1 plus 4. Can make this element as 2 plus 3. And 2 itself will, like this will result in 2 operations to entirely make, although this 2 will itself take 2 operations, this will take 3 operations, but it can act as a building block and this will take 2 operations. 5 if we have 2 and 3 already built up. This can result also in 2 operations, but if we make it as, if we break the 4 into 2 plus 2, then this will result in 2 operations prerequisite. Hmm, 2 plus 2, 2. With the help of this, we can have this 5 with 3 operations. 1, we first make 1, we first have 1, then this is second operation 1, then 2, we make 2, and then we take all these as subsequence. 3 operations for 4 minimum minimum 3 operations. 5 will have minimum minimum 3 operations for 4, minimum 2 plus 1. For 1 we have 1 operation, no, 0 operations, 1 1 because it is present, so 0. And for 4 we have 3 operations, so then we add them. 1 is made, 4 is made, 3, this is 0. So total 4 operations for making 5. 4 operations. This will result in 2 operations to make the 2 first, 3 operations to make 3 first. But we are double counting. Hmm. 2 is made and 3 can be made with the help in one operation only. Some type of recurrence relation, I think, is present. 1 is 1 plus 1. N times 4 times. This is 1. This is 2. If we actually select the subsequence and make this, I think it will be a slow solution. So we have to find something from the test cases to see some trick type or something pattern type. What is the logic? This one takes one operation. This one takes one operation. And then this 3 operations. 3 operations from, if we take 3 and 3, this will 2 0 operations, 2 plus, and this operation itself 3. 1 4 times this one, 3 operations, 4. We can make a number I with I maximum I operations easily. So any number can be built. Any number can be built, but it will expand the array to a bigger size. We have infinite operations, but size is limited. Let's make we will only be having new elements 2 comma 3 1 1 4 can also make 5 This is the sum of all the previous, so not all, like subsequence. You can make 7 6 6 7, can make 8 9, everything. Maximum elements can be, if we take all this, what can be the maximum? can make 6, 7. Maximum will be sum of all 9, 9 plus 2, 11, 11 plus 16. We have a minimum and maximum range at any given point. And minimum is always 1. Maximum is the sum of all the elements. Hmm. Hmm. Maximum is 4 in this case. Maximum is. We can make any element in this range. And we can perform any number of operations to reach there. Okay. The maximum can be 3, 7. The maximum here was 16. So for okay, if we have an if we have only one element, then we can only make max. If it okay, uh, one element we can only make maximum number 1. Two elements we can maximum make 2. And n is 3, n is 4, n is 5. Let's not this. Shift this maximum possible element. This is 1, 2, 4, 7, 16. If we are given a test case whose C, if we are given a C whose size is 2, whose size is 2, but it has at least one element greater than 2, size 2, and it is of type 4 comma, and 1 should be present, if 1 or something. It is for n is equal to 2, the maximum possible element is 2, but it has 4, so it cannot be made. No. This is the case. It should be +1. This cannot be made also, because we will sum them a new element. Okay, so if n is 1 or 2, the maximum possible element we can have is because this addition will append one more element, maximum possible +1. The 16 will be a new element. This is 5 elements and the 16 will be new elements, so 16 can be present. Okay, n should be at least 6 to afford a 16 in your array. No, we have seen maximum possible. Any number of operations. Size should be less than. Important condition is dot size is equal to c dot size. Okay, this thing is I think sorted. If we have any element, if suppose for 6 elements we can maximum have 16. One mm, if C consists of 6 elements, if C consists of 6 elements less than or equal to 16, means this is fine. It can be made or not. Three operations. Two. Made a 2. We can make a 5 here. If it was 4, we can take this 2, this 2, this one 3, and take this 2. Have a 10. Then it cannot. Which is 10. So after every operation we have to check where we are, whether we can make it or not this time. And also we have to keep track of the size. Done क्यों किया? N is greater than to sort given C. Second, keep track of current max 1 N A 1 so move the pointer here, change this. current maximum is 1. Current maximum for current maximum C, current maximum A is this is V. Current maximum C will be AI because it is sorted order is equal to CI. If CI is less than is greater than current max A, max C is 1, max N is 2. Sum which can be made in the next iteration. This is also 1. Enable B3 and this one is now 3. And maximum of 5. Okay. Current maximum now is 10. The new element which we need to push, and the total elements will be 5. But this will fail this, so we cannot make this and we stop. If it breaks, then it return no. If it passes, then if whole pass, then return true. Let's dry run it in one more case. Let's dry run on this given case. CI can have CI table NA current max. So initially 1 1. If the smallest element is not equal to 1, then also if C0 is greater than 1, then return false. Or we can have initially this set as 1 current max. Then we will update it according to the first element. Uh, this should be 1 initially or 2. It should be 1. But at the second element we cannot make 2. So this should be 1. Okay. Now this is less than equal to 2. Current maximum is sum of these two. This is essentially the same thing. You can make this 2. You can make this 2. So this. Some. Now we have 3. This two comparison. This can be made. Oscillations and four. Now some of this is 1, 4 plus 7. This can also be made in the range. We will select a subsequence. This will be made. And at last it will be sum of all this. I think this will be the linear solution in this passing one class. We just have to keep track of the current maximum mean which we can make at any given point, and we will try to build it after the sorting. I think we are ready to go on. And any edge case, if we see other test cases, can this okay? 1 1, and then we can make a 2 because 3 is the maximum. We can make a 4. Okay, because 5 is okay. We are ready. Boilerplate. Minus minus. Int NC is equal to C. Accept it. And now we will have our vector and C. And C will be the size. Ci is equal to 10. Okay. Now we just have to sort first. C not n. We'll try to recall it. If C0 is greater than 1, then return false. Continue. one element cases we can just have c dot size equal to 1 and c equal to 1 and c0 equal 1. Whatever may be the size, if nc is greater than 1, it cannot be made if nc is greater than c0 equal So initially int current max a will be equal to 1. I less than and c I plus if current maximum a is less than ci, then we see out answer yes if current maximum is answer is equal to no, we break out of this loop. Else we can update our current maximum. We have made till that array, so we can just have this print the answer. Let's see. Current maximum will be okay. 1 for this iteration, 2 for this iteration. First one will be added. Okay. 1. If the first element is 1, and for the second it will look okay. Yes, no, yes. One test case. This is no. This is yes. This one 5. Let's see this. Sort 1, 1, 2, 5, 7. Answer should be no. Cause current maximum here will be 1, then here will be 2, and it will be 4. Let's compare with 1, 5, false. This is 1. Let's compare with this. True, so this. Okay. Okay. We will not add for if I is not. At the starting position for first iteration also it responds. Okay. Okay. So, signed integer overflow. Yes, it can be fixed easily. We will have a long fixed. Logic is correct. Let's just once again go through this. Let's see. Okay. Watch it. Okay, got this accepted. We will see the what were the hints on this. Grady with prefix sums. Okay. Smallest isn't 1. Okay, it is false. Why must each not exceed the currents? We arrived at this logic. Okay. Yes. So yes, we found out the way. Now I will end the live stream. Bye.